Hello, students. Now we are going to talk about catalysis. This is a simplest topic in chemistry, likewise in physical chemistry, main part of the kinetics. But it's have wide range of applications, say in industrial chemistry, especially in the manufacturing industries or paint industries. Likewise, let's we know that that's a base we have to know the basic requirements and basic things, types, classifications, and definitions. What are the theory behind this catalysis? So let's move on. This catalysis is mainly focused on the name is catalyst. That name is comes from John Jacob Berzelius, the Sweden chemist, and Oswald from Germany, German chemist. Now we know that catalysis it's a process, and then a catalyst is a substance which increases the rate of the chemical reaction without any alteration takes in the reaction. This phenomenon is called catalysis. This graph shows that we know that there is a activation energy or some energy needed to reaction progress. Now, this is a two graphs. One is in black color and another one is red color. Here, the black one shows that the energy of the reaction without catalyst, and red one shows that the energy with catalyst. We know that we should show the difference between the energy of no catalyst and with catalyst. This energy consumption is on truly based on the catalyst action. The theory behind the catalysis. There is a two type of theory in catalysis. The one is intermediate theory. We know that the intermediate is very less stable. So in the reaction progress, there is a reaction between the reactant, then it form an intermediate. This intermediate is very reactive and less stable. Then this intermediate decomposes to give the final product in two steps. And the other one is absorption theory. Absorption theory is mostly used in the reaction between gases and the solid catalysis. It's a heterogeneous catalysis. Here the figure shows that there is a catalyst surface shown in blue color. The reaction takes place in the surface of catalysis. The first one is adsorption. Here the oxygen adsorbed in the catalyst surface. Then it reacted to form carbon monoxide, then desorption. This desorption, it's a leaving the surface of catalyst, then give a products. These are the two types of the theory in catalysis. And then types of catalysis. There is a widely two types of catalysis. The one is homogeneous catalysis and another one is heterogeneous catalysis. Homogeneous, we know that homo which means same. So here the reactants and the catalyst are in the same phase. For example, in lead chamber process there is a sulfur dioxide, oxygen. The both are in gas phase. And the catalyst is what's that? It's a nitrogen oxide. This also in gas phase. Here the both reactants and nitrogen oxide in both are in same phase, gaseous phase. That's why it comes under the category of homogeneous catalysis. Then another one is hydrolysis of ester. Here the ester and hydrolyzed by water in the presence of HCl catalyst. Here the ester and water itself is a liquid and acid is a liquid. This also a homogeneous catalysis reaction. And another one is hydrolysis of sugar. Here the sucrose solution, it's a liquid form, and water in liquid form. Here the sulfuric acid acts as a catalyst in liquid form. So these are some examples of homogeneous catalysis. And another one is heterogeneous catalysis. Here the reactants and the catalyst both are in different phase. For examples, contact process, Haber process. In contact process, we know this is the manufacture of sulfuric acid. Here the use of sulfur dioxide and oxygen, both are in gas form. But in catalyst, we know that the catalyst is what? It's a platinum. It's in powdery form. Likewise, it's a solid form. So here the catalyst in solid form and the gases in gas forms. So this is example of heterogeneous catalysis. And Haber process, the manufacture of ammonia. Nitrogen and hydrogen both are in gaseous phase and iron in sulfur solid phase. And in Oswald process also ammonia and oxygen in gaseous phase, platinum catalyst is in solid phase. So these are the some examples of heterogeneous catalysis. And the most important types in homogeneous and heterogeneous. Other side, there is some types of catalysis is there. The first one is negative catalysis. Here the name itself carry out the meaning. It's a negative. So any substance as added to the reaction, it's retard or slow the reaction rate. So this is known as negative catalyst. For example, the oxidation of sodium sulfite. Here the use of alcohol, it's a negative catalysis. As it suppresses the reaction rate. And the oxidation of benzaldehyde, here also the diphenylamine act as a negative catalyst. So we know that we are using bike, right? So it's a tetralethyl. It suppresses or retard the betul compression, so it's minimize the gas engine consumption. So this effect is known as knocking effect. And then autocatalysis. Autocatalysis in a certain reaction, one of the product formed in the course of the reaction that act as a catalyst. Here the example of oxalic acid with carbon MnO4. Here the formation of magnesium 2 plus ion, which found the during of a reaction, it's act as a catalyst. Then another one is catalytic promoter. Catalytic promoter, which is catalyzes the catalyst, but it increases the efficiency of catalyst. For example, in Haber process, used iron as a catalyst and molybdenum as a catalytic promoter. And catalytic one, which suppresses the efficiency of catalyst. For example, used in arsenic oxide in contact process. And enzyme catalysis. This is the most important topic in catalysis, enzyme catalysis, which also known as biocatalysis. Here, the reactions are carried out by the use of enzymes as a catalyst. So, enzymes are proteins which can act as a catalyst in biochemical reactions or biological reactions. So, first one is hydrolysis of sucrose. In the presence of invertase as a catalyst, it forms glucose and fructose. And the glucose in the presence of cymase is converted then alcohol. This is a simple examples of enzyme catalysis. Then we move to the enzyme catalysis of mechanism. This one is a very simplest mechanism of enzyme catalysis, like lock and key mechanism. We know that the action between lock and key. Here the lock have a specific void which is designed by the key. It's able to fit in the void of lock. Then it's locked and unlocked. Here also the same. Here the substrate comes under the enzyme surface. Its enzyme have a specific void for a substrate. Substrate is nothing but a reactant. Then the complex formation takes place. Then the reaction. This complex enzyme product complex formation then dissociates into give enzyme plus product. This is a very simplest mechanism. Okay. So finally, summarize this catalysis. It's a catalyst. It's likewise is alter the reaction rate. And then there is two theories. One is intermediate theory and absorption theory. Then we move the types. Types is it's two main types. One is homogeneous and another one is heterogeneous. Okay, homogeneous which means same phase and heterogeneous which is different phase. There is a lot of classification or types in catalysis, such as negative catalysis, orthocatalysis, catalytic promoters, and catalytic poisoning. Then we move to the important catalysis, enzyme catalysis. Then we saw the mechanism of enzyme catalysis. Student, I hope you can understand this catalysis topics very well. Then we will see in the next presentations. Thank you.